Good morning, everybody. Hope you're all healthy and safe at home. So let us continue with our section 9.9, Independence of the Path. So in the previous lecture, we had seen how to find whether the given vector field is conservative or not. And we had done some few examples of our textbook regarding the same. So doing the assignment problems, I hope it has been a thorough concept inside your mind that how can we determine whether the given vector field is conservative or not. So in this lecture, what we are going to do is, once we know that the given vector field is conservative, then the next question which comes in our mind is how can we find the potential function of that particular vector field, right? How do we do that? We know if the field is conservative, f will be equal to grade phi, right? So first what we do is we are going to equate f is equal to grade phi. So if f is pi plus qj, then P is equal to dou phi by dou x and Q is equal to dou phi by dou y. Now to find this, we are going to remember few steps, basically the 4 steps which I am going to show right now. Keep these steps in your mind and you can do the problems easily. So first we have equated it. Then what we are going to do is we are going to integrate dou phi by dou x with respect to x, and we will get phi. When we integrate dou phi by dou x, we will get the expression of phi. But in that expression, there will be a term g of y, which will be the integrating constant. So we have to find g of y also, right? So for that, what we do is we will partially differentiate the expression that we have obtained, and in that partially differentiated expression, we will have g dash of y. So once we obtain phi in terms of g of y, what will be partial differentiation of phi with respect to y? That will be dou phi by dou y, and in dou phi by dou y we'll have an expression of g dash of y. Now remember the first thing that we did, we had already calculated what is dou phi by dou y, that is nothing but q. So next what we do is we will equate these expressions and compare the obtained expression with dou phi by dou y, and we will obtain g of y. So once we get g of y, we will get the value of phi in terms of x and y. So these are the basic 4 steps that you have to keep in mind to do the problems regarding to a determination of the potential function phi of a conservative vector field. So now let's do a problem which is given in your textbook as an example. The example 7, it has 3 parts. The first one is to show that integral over c f dot dr, where f of xy is y square minus 6xy plus 6i plus 2xy minus 3x square minus 2yj is independent of path c between -1, 0 and 3, 4. So let's do it step by step. The first part is we have to show whether this integral is path independent. Now from the expression of f, we get p is equal to y square minus 6xy plus 6 and q is 2xy minus 3x square minus 2y. Now what will be the value of dou p by dou y? Dou p by dou y is partially differentiating p with respect to y, keeping x as a constant. So we get 2y minus 6x. Now we'll find what is dou q by dou x. What is dou q by dou x? We have to partially differentiate q with respect to x, keeping y a constant. So what do we get? We get partial differentiation with respect to x, we get 2y minus 3 into 2 is 6, and y is a constant, so this becomes 0. So from this we get dou p by dou y is equal to dou q by dou x, because both are 2y minus 6x. So we can conclude that the vector field f is conservative using theorem 9.9.1. 4. And since it is conservative, we can say that the integral is independent of the path using the theorem 9.9.2. We can easily prove that this is which we have done before. So since the field is conservative, the integral is independent of the path. Okay. Now let's move on to the B part of the example. That is, we have to find a potential function phi for f. So in the first part we had seen that f is conservative. So if f is conservative, we will definitely be able to find a potential function. So how do we do that? Just remember the steps that I have mentioned before. First, we will equate p equal to dou phi by dou x, that is y square minus 6x plus ys plus 6xy plus 6 is dou phi by dou x, and dou phi by dou y will be q, that is dou phi by dou y is equal to 2xy minus 3x square minus 2y. Next, what we have to do? We have to integrate this term dou phi by dou x with respect to x. Okay, so integrating, what do we get? We get integral of y square minus 6xy plus 6 dx, which is xy square minus 6xy will be 6y into x square by 2, that will be minus 3x square y plus 6x plus g of y. Here g of y will be the integrating constant. Next, what do we have to do? We will differentiate this expression phi is equal to xy square minus 3x square y plus 6x plus gy partially with respect to y. So that is, we will obtain dou phi by dou y. What will it be? With respect to y, keeping x as a constant, that is 2xy minus 3x square, and 6x is a constant, so this differentiation will become 0, plus g dash of y. Now we don't know what g of y is. It can have term containing y or x, whatever. So differentiation of g of y will be g dash of y. So what is dou phi by dou y? That is 2xy minus 3x square plus g dash of y. Now we already know what dou phi by dou y is. That is 2xy minus 3x square minus 2y. So we will compare these two. So that is 2xy minus 3x square plus g dash y equal to 2xy minus 3x square minus 2y. So from these two equations, what do we get? We get g dash of y equal to minus 2y. Now from this we can easily obtain what g of y is. How can we obtain? We have to integrate this. Integrating this expression, what do we get? G of y will be minus 2y, integration is y square by 2, so 2 and 2 get cancelled. So we get minus y square plus c, where c is the integrating constant. So what will be the value of phi? Phi will be xy square minus 3x square y plus 6x plus g of y is nothing but minus y square plus c. So phi is xy square minus 3x square y plus 6x minus y square plus c. Now let's see what is the c part of this example. We have to evaluate the integral. Now you know that if the vector field is conservative and if we can find a potential function for f, then we know integral over c f dot dr is nothing but phi of b minus phi of a, right? That was in theorem 9.9.2. That is how we can determine the integral value. That is, we know what phi is. So integral minus 1 comma 0 to 3 4 f dot dr is nothing but phi of x comma y varying from minus 1 comma 0 to 3 comma 4. Okay, and we know what phi is. Phi is xy square minus 3x square y plus 6x minus y square. Here when we have to calculate the integral, you don't need to consider the constant term c. So what will be the value? We'll substitute 3 comma 4. What will that be? You can just substitute and we will obtain that it will be 48 minus 108 plus 18 minus 16 minus, we'll substitute phi of a. What is phi of a? It is minus 1 comma 0. So whenever there is y, those terms will get cancelled because y is 0 and x is minus 1, so we get minus of 6, and summing up we'll get the value to be minus 52. So this is how we go about doing the problem to determine whether the given function is conservative, and that is determined by just verifying if dou p by dou y is equal to dou q by dou x, and then we will do find the potential function corresponding to the conservative vector field. And for that you have to just keep all these 4 steps in your mind. First we will equate p equal to dou phi by dou x and q equal to dou phi by dou y. Then we integrate dou phi by dou x with respect to x, and we'll obtain phi in terms of g of y. And then what do? We partially differentiate that expression of phi, and we will obtain an expression which contains g dash of y, and we will equate that expression with g dash of y with dou phi by dou y which we had initially obtained, and we'll get the expression of g dash of y, and finally we obtain g of y, and hence we obtain the potential function. Now once we know what the potential function is, then it will be easy to determine the integral value, the value of the line integral using theorem 9.9.2. Integral over c f dot dr is equal to phi of v minus phi of e. So I hope it is clear for you guys. With this we'll wind up today's section, and we shall do more problems regarding the same. So that's it. Thank you. Stay home and stay safe.